Hello everyone, welcome to my channel Learning from Data. Today I'm going to talk about outlier detection. Outlier, it is a buzzword in the manufacturing industry. It has driven engineers and scientists to develop new algorithms as well as robust techniques for continuous quality improvement. If the data includes even one outlier, it has the potential to dramatically skew the calculated parameters. Therefore, it is very important to analyze the data without those deviant points or extreme points. It is also important to understand which of the data points are considered as outliers. Extreme data points do not always necessarily mean those are outliers. Those can be some just extreme values, and the intermediate data are not yet there. In this article, I will discuss the algorithm and the Python implementation for some outlier detection techniques. These techniques will include IQR method, standard deviation method, ZScore, and modified ZScore. So let's begin. The very first outlier detection method that I'm going to discuss is IQR. IQR stands for interquartile range. Interquartile range is one of the most extensively used procedure for outlier detection and outlier removal. According to this procedure, we need to follow some of the steps that I'm going to discuss here. To demonstrate the IQR method implementation, I need to show this box plot. Box plot is very handy to demonstrate this IQR method implementation, which includes the lower whisker, the upper whisker, the quartiles, like the lower quartile, which is denoted by Q1. Here we have also median, which is Q2, and we have also the upper quartile, which is Q3. This is also called, the Q1 is also called the first quartile, the median is called second quartile, and Q3 is called third quartile. And the difference between Q3 and Q1 is called interquartile range. And we have the maximum value here, and we also have the minimum value here. The region between the maximum value and Q3 is called upper whisker, and the region between the minimum value and Q1 is called the lower whisker. To detect outlier in this IQR method, first of all, we need to find the values of these quartiles. For example, we need to first determine the first quartile, that is Q1, and then determine the third quartile, which is also called upper quartile, which is Q3, and then calculate the interquartile range, that is Q3 minus Q1 here. And we need to define the normal data range with the lower limit as Q1 minus 1.5 times IQR and the upper limit as Q3 plus 1.5 times IQR. Therefore, the lower limit and the upper limit for this procedure of detecting outliers are these: Q1 minus 1.5 times IQR, and the upper limit is Q3 plus 1.5 times IQR. And any data point which are outside this range are considered as outlier, and it is the user's decision whether those outlier points should be removed from further analysis. This is just a snapshot of the box plot statistics which are implemented in Python. I will share all the code details in the description section of this video. There you can see the GitHub page, and you can also open it in Google Colab or in Binder and practice this. For this article I have used open source Airbnb data. I will also share the link. From these statistics, we can see that the mean, the interquartile range, and the upper whisker and the lower whisker. We have the flyers here. Flyers mean the outliers, and the Q1, Q3, and the median value, which is Q2 here, are shown here. From these statistics, we see that there is one outlier value, and the value is here 417, and we can see that Q1 is 95, the median is 150, and Q3 is 220, and this value is an outlier on the higher side. That means we have an upper limit of Q3 plus 1.5 times IQR, and this value lies beyond that range. That's why it is called a flyer or an outlier. The outlying value is shown here in this box plot. You can see this point, this tiny dot is above the maximum limit of this box plot. The value of this tiny dot is 417, which is shown here. The next outlier detection method I'm going to discuss is standard deviation method. It is very much similar to the IQR procedure that I discussed before. Depending on the set limit, either at 2 times standard deviation or 3 times standard deviation, we can detect and remove outliers from our dataset. Therefore, we can set the limit depending on our interest or our need. For example, we can set our upper limit at mean plus 2 standard deviation if we want to be too much stringent, or we can make the upper limit at mean plus 3 standard deviation if we want to open up the spec a little bit. Same for the lower limit. You can set at mean minus 2 sigma or mean minus 3 sigma. The Python implementation is shown here at the bottom. In the Airbnb data that I used here has a column named price, and which is a numeric column, and I used that column to demonstrate the standard deviation implementation. Here I have used 3 sigma limit, obviously mean minus 3 sigma and mean plus 3 sigma as the lower limit and upper limit respectively. From this histogram on the left side, you can see that the 3 standard deviation limit is here, roughly here, and it basically says that if we set that mean plus 3 sigma limit as our upper limit for outlier detection, all these points will be considered as outliers. You can see that this is basically a right skewed distribution. This is not a normal distribution, and if we implement this mean plus 3 sigma standard deviation as an upper limit, we will lose a bunch of data points over here. There are some other algorithms or techniques for skewed distribution, but we'll discuss that one later. But for this kind of skewed distribution, we can do the 3 sigma limit, but we will lose a lot of data points if we remove it later. Here on the right side, in the box plot, you can see there are a bunch of dots over here. Compared to the IQR method previously discussed, we only have 1 data points that was an outlier, but here we have a bunch of data points which are considered as outlier. The third procedure for outlier detection that I'm going to discuss is the ZScore procedure. ZScore is just another form of standard deviation procedure. ZScore is used to convert the data into another dataset with mean equals 0. Let's say we have all the data points denoted by xi, and x bar is the mean of the dataset and s is the standard deviation. Then z-score is calculated from this equation. We need to subtract the mean from each and every data point, and the resultant is divided by the standard deviation. Since we are subtracting the mean, and if we go for a distribution for all the z-scores, we will get a mean at 0, and we are also dividing this result by the standard deviation. Therefore, the resultant z-scores standard deviation will be equal to 1. We have the z-score distribution shown here for the price column for the same data. We can see that the mean here is 0 with a long tail distribution on the right side. Obviously the standard deviation will also be 1 since this is a z-score distribution. Once the data is converted to z-score, the center becomes 0 and the z-score corresponding to each data point represents the distance from the center in terms of standard deviation. For example, a z-score of 2.5, for example, maybe the data point is somewhere here. A z-score of 2.5 indicates that the data point is 2.5 standard deviation away from the mean. Usually a z-score of 3 is considered as a cutoff value to set the limit for outlier detection. Therefore, any z-score greater than plus 3 or less than minus 3 is considered as an outlier, which is pretty much similar to the standard deviation method. Here you can see the resultant data points once the z-score is implemented. These data points are still considered as outliers from the z-score procedure. The last method that I'm going to show you is the modified ZScore method. Why do we need a modified Z-score if we have a Z-score already in place? The reason is Z-score is very much susceptible to extreme data points. If there is one extreme value in the data points, the Z-score corresponding to that point will also be extreme, and it has the potential to significantly move the mean away from its actual value. On the other hand, the modified z-score is somewhat more robust than the standard z-score, since it is calculated from median absolute deviation, which is also called MAD. The formula for the modified z-score is shown here, which is 0.6745 times xi minus x bar divided by MAD. Since the modified z-score relies on median value instead of mean, it is less susceptible to any outlier. We can use the cutoff value of modified z-score at 3.5. I will share the reference link for this. Once this procedure is implemented, we obtained the same result as z-score, since the dataset probably doesn't have any influential outlier. It may have outlier but may not have that much influential outlier that can change the result. The statistics from the modified ZScore is shown here. We have also the flyers, which are outliers here, and the values are shown here. And the same outliers what we received from ZScore are also obtained here in case of modified ZScore. As I said, we don't have any influential outlier in this case to change the result. In this article, I have shown 4 statistical procedures of detecting outliers in the dataset. For normal dataset, IQR multiplier of 1.7 is similar to a standard deviation multiplier of 3, which is also similar of setting the cutoff ZScore at 3 as detection limit. The essence of this statement is we can deploy any of these outlier detection method and get the same result. For example, IQR multiplier of 1.7 will provide the same result as we set the standard deviation multiplier of 3 or Z-score multiplier of 3. Statisticians use modified Z-score to minimize the influence of outliers on Z-score. The modified Z-score indicates the relative strength of that outlier and how much it deviated from the original Z-score it was supposed to have. All these procedures are standard procedures to determine outliers statistically. Well, we are here towards the end of this video. Hope to see you in the next video. Thanks for watching.